All right, guys, on to number 26. This one it's another percentage problem. So again, a quick reminder: if you have percentages, if it says in this case, percent more. So if you're going up a percentage, remember what you're going to do is you're going to go 1 plus that percentage written as a decimal, and if it's down a percentage, then you're going to go 1 minus whatever that percentage is as a decimal. Now the other thing you want to make sure that you're doing on these is that you are going to automatically be multiplying by that percentage or whatever that number is. So in number 26, we have that phrase used, 20% more. I'll talk about that in a second. But Katerina is a botanist. She's studying the production of pears by two types of pear trees, and she noticed that type A trees produce 20% more. So as soon as I see the phrase 20% more, 20% more, I know that I'm going to multiply at some point in this problem by the number 1.2. And I'll put the 0 there just as a reminder. But I'm multiplying by that number. Now I just got to figure out what I'm going to multiply that number by, but I know it's going to be in the problem. So we know that type A trees produce 20% more than type B. So if I had type A and I had type B, and let's say I set them equal to each other, I know that 1.2 has to get multiplied somewhere. So the question is where? Well, again, it's saying A made more, 20% more. So this number is bigger. So I have to multiply something by 1.2. So that number is going to be the smaller one if you want to make them equal. So this is the equation that you'd be setting up. Now you could say A is, which means equals, 20% more than, so 1.2 B. And you can use converting equation concepts and you can write it out that way as well. But in the end, you're going to need that equation. And they're telling you type A trees produce 144 pears. So I know that A is going to be 144. And that equals 1.2 times B. So I'm just going to divide both sides by 1.2. And then when you divide that, you're going to get B is equal to 120. So we're looking for the answer 120, which is going to, well, be B. That's convenient. So number 26 is going to be B. Moving on to number 27. We have a square field. Now this is measured 10 by 10, and we have 10 students each mark off a randomly selected region. Each region is a square and has side lengths of 1 meter. Give you a quick, I'm not going to make a pin that has 100 boxes in it, but just to give you like a quick idea, this is not to scale because I'm not making 100 boxes, so it's not 10 by 10, but just to give you an idea, we have a 10 by 10 field. And we have 10 students that randomly picked some regions here. So it's not all of them, but it's just 10 random ones. And that's, again, not to scale or anything like that. So the students count the earthworms in each one of those little 1 by 1 squares, or cubes, really, because it's three-dimensional. And then that's what the results are going to be in that table below. So that's what this represents, a sample size of this field, using 10 out of the 100 squares that there are in the field. And that's what we're looking at right here. So from that information, which of the following is a reasonable approximation because you're going to have to kind of use the sample to guesstimate the final amount, for the number of earthworms to a depth of 5 centimeters in the entire field. So here's what I know. Right now, I have, using this, I mean, again, this isn't to scale or anything, but I have right now 10 out of 100 squares that I have data from. I want to know how much the entire field holds. So we can do this using simple arithmetic, or if you want to do like a conversion, what we would do is we would take this conversion and say, well, how many earthworms are there in these 10 fields? So you would add up all these numbers right here. So you're going to add up everything that's listed here. So we're going to take this column in this column and get a total, and that's going to add up to 1,471. That is out of how many earthworms, and you can set it up like a proportion, just like this. In the end, what you're going to do is the same math regardless. But this is going to be 10 times t, which represents the total number of earthworms, approximation, and that's going to equal 1,471 times 100. So we're just going to add 2 zeros to that, and we're at this number right here, 147,100. So divide by 10, and you're going to get the approximation here of 14710. I'm taking away a factor of 10, so I'm taking away a 0. So I end up with 14,710, which the closest number we have is 15,000. So that is going to be C. So that's going to be number 27. Now the quicker version is just to realize I only have 10 samples, so the other option here is to say, well, if I have 10 of them, I'm going to multiply whatever those 10 add up to by 10, and you could have just gone 1,471 times 10, and that would have gotten you here as well. A little quicker. I just want to show you it is basically a conversion at its core. So that's what you're going to do for number 27. Number 28, that's going to be a system of inequalities. This is just a graphing problem. So they want to know, they're giving you these two inequalities, and they're just asking you what region do the solutions fall in. So I need to graph these and see what regions the solutions lie in. So this is graphing a slope-intercept form equations. There are two of them. I'm going to number them for you real quick. So that's 1 and 2. So when I'm working with each one, you know which one I'm working with. And I'm just going to set up a quick XY plane. I'll do it down here. So when I am doing all this work, I have some room to work with here. But that's my basic sketch. So let's do this. So equation number 1. What we want to know first is equation number 1. I'm just putting this up here in case I need it. But I know it has a y-intercept of 1 and has a slope equal to 2 over 1. So I'm going to go ahead and put that on my graph. I have a point at 0, 1, and I'm going to go up 2, right 1. So that's going to put me here. You can go down 2, left 1 if you would like, but this is going to be your line, and it is a solid line, although that doesn't really matter, but it's solid. My marker's dying here, but there's your first line. Your second line, you're looking at this y is greater than, so this is going to be equation 2. Again, your y-intercept in this case is going to be -1, and your slope is 1 over 2. So I'm going to put a point at -1, and I'm going to go up 1, right 2. And these lines, this is a dotted line, they do intersect over here in the third quadrant. So that is the graph. Now what we need to do is we need to pick a test point here to see how well this, or what region I should say these answers are going to overlap in. So I'm going to go ahead and pick the test point that I usually want to use in these scenarios is always going to be 0, 0, unless the line goes through 0, 0, then you just pick another point. But these don't touch at 0, 0, so I'm going to pick that as my test point. So with equation 1, if you plug in 0, you're going to get 0 is greater than or equal to 0 plus 1. So 0 is greater than or equal to 1, which is false. If you go to equation number 2 and you plug in 0, 0, you get 0 is greater than 0 minus 1. So 0 is greater than -1, which is true. So we want to see where that overlap's going to occur. Well, if you look here, equation number 1, which is the one that started up here at 1. So here's equation number 1. I'm going to shade this one this direction. So it's going away from the point 0, 0 because that answer is false. This one though, equation 2, the dotted line, it's going to shade towards 0, 0. So this one is going to shade here and here. So I want to see where the overlap's going to be. So if you kind of look, you'll see on this, there's kind of like this region right in here. This is where that overlap is happening. So as I kind of shade all that in. So that's where that overlaps. So you can see like this one is shaded on top, and on top that's where they both are going to have solutions. So anyway, you want to see what regions do we get here? Well, right here we get, or quadrants I should say, we get quadrant 1, we get quadrant 2, and we get quadrant 3. Quadrant 4, there's nothing over there. So we're looking for the answer that says which of the following quadrants contains no solutions. That's going to be quadrant 4. Quadrant 4 has nothing, so they're sad. So that's going to be answer choice C. That's going to be quadrant 4, and that's the answer to number 28. Moving on to number 29. This one is giving you the value of P of 3. So they're saying P of 3 is negative 2. And that's really, they're not really giving you much. They're saying which of the following must be true about P of x. Now notice when you look at these answers, the one that should stand out is the right answer, but it's because of a theorem called the Remainder Theorem. So in this case, what you need to know this Remainder Theorem to be able to do this question. So the way it works is, if you have P of x, or P of x equals r, that means P, and I'll call it P of c and not x, so we don't have overlapping variables here. So let's say P of c equals r. Well, what that means is if you take that function, P of x, and you divide it, so if I take this function right here and I go and divide my P of x divided by x minus c, I'm going to get a remainder equal to r. And this is basically what the Remainder Theorem is stating. And this is pretty much all this question is doing, is just seeing if you know this theorem, because they're telling you the remainder when P of x is divided by x minus 3, notice that's my c value, is going to be negative 2. And that's what I have here. So notice they basically gave me this in the question, and they're giving me this as an answer. So I'm just looking for that theorem being stated almost word for word using these actual numbers. So D states the Remainder Theorem, so D is your answer. And again, there's no work to this, it's just knowing that theorem. So if you don't know it, make sure you study it, because it makes the problem fairly easy, and we're on the hard ones right now. So that's it. Sorry, that's it for number 29. Now number 30, they're giving you this, this graph. Now pay attention, again, we're on number 30. Please pay attention to the question. Don't think, this is one that makes you think that this could be super easy until you realize the wording of the question. So this one, they're giving you a graph, and they're saying which of the following, so which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation. So what we have to look at is say, what's the vertex for A? Well, you can kind of see it on the graph without really having to look too hard. It looks like it's probably around 1, negative 16. And you can do that just by looking at the graph. So what they're telling you is the coordinates of A have to be identified as constants. So you have to see those numbers in the equation. If you don't, it's incorrect, which means answer choice A, B, and C are automatically ruled out because they don't have 1 and negative 16 in the answer choice. What they're really trying to tell you in this problem is they want you to put it in vertex form, because that's the one that states the vertex. So vertex form is y equals a x minus h quantity squared plus k. And you may look at this and see, oh, well, answer choice A has the x-intercepts in it. And while that is a equation, it is a form of this equation, it doesn't necessarily make it the right equation. It may not have the proper vertex in it, just has the right zeros, but that's the one they're going to want to get you to pick. But again, you look for the vertex form that has 1 and negative 16 in it. That's D, that's your answer. So we're going to go with that and really avoid all the traps that may already be there. And that's going to be number 30.